Hey everyone, ever tried running a massive AI model on your computer, only to watch it crash? You're not alone. Large models are like supercharged cars. They're powerful, but they need a lot of fuel. Today, we're diving into a breakthrough called EMLoC, a technique that lets you fine-tune 38 billion parameter models on a single consumer GPU. Let's break down how it works and why it's a game changer for AI development. Here's the core problem. Fine-tuning large AI models, like those that diagnose medical images or write code, requires adjusting billions of parameters. It's like rewriting an entire book to fix a single sentence. Traditional methods force a trade-off. Use a tiny model which lacks precision, or a massive one that crashes your system. But what if you could get the best of both worlds? That's where EMLoC comes in. So how does EMLoC solve this? It creates a lightweight emulator, a smaller, smarter version of the model that mimics its behavior. Think of it as a training dummy that learns the same skills as the original, but uses far less memory. This emulator acts as a bridge, allowing the model to learn efficiently without overloading your hardware. The magic lies in LoRA, low-rank adaptation, a technique that adjusts just a few key parameters instead of the entire model. It's like adding training wheels to a bike, rather than rebuilding the whole thing. By focusing on these critical adjustments, LoRA drastically reduces memory usage while preserving performance. But here's the catch. Emulators can drift from the original model's behavior. That's where LoRA correction steps in. It's a calibration process that aligns the emulator's changes with the real model, ensuring precision. Imagine training a robot to dance. LoRA correction makes sure its moves match the original design, no wobbles, no mismatches. Now let's get technical. EMLoC uses SVD, singular value decomposition, to simplify the model's calculations. SVD acts like a filter, retaining the main features of the data while discarding finer details. This reduces memory demands, but can create tiny performance gaps. Think of it as a slightly less sharp photo. Researchers are already addressing this by refining how the emulator interacts with the model, recovering those lost details without sacrificing efficiency. The results? EMLoC lets you fine-tune massive models on a standard laptop, using just 14 GB of memory, compared to 22 GB for other methods. It works across modalities, from text to code to images without compromising quality. And it doesn't need a mountain of data. In tests, 3264 examples were enough to calibrate the emulator. That's a huge win for researchers with limited resources. Why does this matter? EMLoC democratizes AI development. No more choosing between power and practicality. Now, hobbyists, students, and small teams can customize AI for their needs. Whether it's analyzing X-rays, writing essays, or building apps, the barrier to entry is lower than ever. So next time you see an AI doing something amazing, remember, tools like EMLoC are making it possible, one memory-efficient step at a time. Thanks for watching, stay curious, and let's keep pushing AI's limits.